All right, class, we are going to be learning about matrices today. So let's start off with some definitions. So matrix is going to look just like this. Okay, so it is a rectangular array of variables or constants in a row or columns. Let me in rows or columns. Usually enclosed in brackets. Just like we have here. All right, so now elements are the individual values within the matrix. Element AXY is used to denote each element where X is the row number and Y is the column number. We're going to take a look at what that means in just a second. Is the column number where the element is located. So one thing also to note is matrices are named using a capital letter. So let's fill in this example here. So given a matrix A, find the values for each element. So A with a subscript of 2, 5. This is telling us that looking over here, we're looking at row, because remember it's always X comma Y. So this is the row, this is the column. So in looking at that, we're looking at row 2. So here's row 2. Column 5. So here's 1, 2, 3, 4, 5. So row 2, column 5, that's this value right here. And so that's how we get -2. Let's try this one. This is 3, 1. So that's going to be row 3, column 1. So that's this number right here. So at 12 here, it's going to be row 1, column 1. Sorry, row 1, column 2. So that's going to be 40. At 8, 3, 4, we're looking at row 3, column 4. So it's going to be 52. Number 5 here looks at row 1, column 5. So now we're looking at 21. 8, 2, 2, so it's going to be row 2, column 2. So we're looking at 32. All right, let's talk about dimensions here. So a matrix with m rows and n columns is said to be let's change colors here just briefly. M by N matrix. So we're always going to say the rows first because we're going to always say it as M by N. So here's our M rows, N columns. So rows by columns. So in the next one, it says state the dimensions of each matrix. So we're just going to take a look at the dimensions. So how many rows do I have? I only have 1 row. How many columns? I have 1, 2, 3. So this is going to be a 1 by 3 matrix. 1 row, 3 columns. Okay. When I look at number 8, how many rows do I have? I have 1, 2, 3, 4. So it's going to be a 4 by, and I have 2 columns. so 4 by 2. Over here I have 3 rows by 1, 2, 3, 4 columns, so it's going to be a 3 by 4. And lastly here I'm going to have a 2 rows by 1, 2, 3, 4, 5, 6 columns. So I have a 2 by 6. Okay, so this is how we state the dimensions of a matrix. So if we ever say a 3 by 3, that's saying 3 rows, 3 columns. Equal matrices are going to be 2 matrices in which each element in one matrix is equal to the corresponding element in another matrix. Okay. All right, let's take a look at these specific special types of matrices. So a row matrix is going to look like one row. So like A, B, C, this would be a row matrix. A column matrix then is going to be column, something such as X, Y, Z. A square matrix will look something like 4, 9, 5, -2. And then a zero matrix would be a matrix of all zeros. So those are special types of matrix. So a zero matrix is just going to be a matrix filled with zeros. Okay. All right, let's talk about adding and subtracting matrices. So when we add and subtract matrices, they can only be added and subtracted if and only if they have the same dimensions. So simply add and subtract the corresponding elements. So if I look at X and Y, I'm going to look at X and Y, and notice they are both a 2 by 3 matrix. So this means that I can indeed add them. So now that I can indeed add them, let's go ahead and add them. And so we're going to do, the corresponding matrix is going to be 24 minus 15. So 24 minus 15, that's 9. Then I'm going to take -8 and subtract, and add 29. So it gives me 21. -3 plus 17 gives me 14. -4 plus 9 gives me 5. 6 plus -5 gives me 1. And then lastly, -17 minus 2 gives me -19. So again, we're adding the elements. So everything in x11, right, is going to be added to y11, right? So all the elements in the x that are in that first row, first column are going to be added to the y first row, first column. That is how the addition plays out. So this is why it's important that the matrices be the same size. All right, let's take a look at the next one. So I have Z minus W. So do check, this is a 3 by 2 matrix. This is also a 3 by 2 matrix. So that means that that would check out. So let's go ahead and subtract them. So in subtracting them, -3 minus -1, right, we're going to have -2, -11, -5, -15, 4, and 29 as the values. All right, W plus X. Right? Now the next question is this possible? Can I do W plus X? So if I look at W plus X, notice that they are both very different dimensions. So this is actually not possible. x minus y. So if you take x minus y, so now we're going to be subtracting them, unlike last time where we added them. So when we combine them, we should end up with 39, negative 37, negative 20, negative 13, 11, and negative 15. Again, we're taking element by element. So negative 4 minus negative 9 is going to give me that negative 13. Okay. Now let's look at scalar multiplication. So matrices can be multiplied by a constant called a scalar. In this process, we're called scalar multiplication. Each element in the matrix is multiplied by the scalar to produce the new matrix. So when I say 3 times x, this is really saying 3 times every single item in x. And so let me go ahead and write down that matrix. So the x matrix is going to be 24, negative 4, negative 8, 6, 3, negative 17. So now if I'm going to multiply this by a scalar of 3, I'm taking each individual element and multiplying it by 3. So I'm going to do 3 times 24, which will give me 72. 3 times negative 12, sorry, 3 times 3, 3 times negative 4, which gives me negative 12. And then I'm going to end up with negative 24. 3 times 6 gives me 18. So then I get a negative 9. 3 times negative 17, it's going to give me a negative 51. So that's how we do scalar multiplication. Okay, let's look at the next one. And 3/4 of w. So 3/4 times w. And now w was negative 1, negative 11, 8, 9, 15, negative 20. So when we do the scalar multiplication, right, that means we're taking that fraction, we're multiplying it by all the w's. So I would end up with negative 3/4, negative 33 over 4, 6, 27 over 4, 45 over 4, and negative 15. All right, so now we're going to combine both of those elements here. So we have both scalar and addition. So first we're going to take the scalar and multiply it by our x value. I do have x already written up here. So it's going to be 5 times our x, which is 24, negative 4, negative 8, 6, negative 3, negative 17. And then I'm going to add 2 times the y value. Oh, that's a negative 5. 2 times that y value, and that y matrix is negative 15, 29, 17, 9, negative 5, negative 2. So now when we multiply by the scalar by that negative 5, remember we're multiplying every element times that negative 5 to change the inside of that matrix. So in doing that, we get this new matrix. So for instance, negative 5 times 24, that's going to give me a negative 120. That becomes our new element. Okay. So negative times a negative, that's positive, so we have positive 20. Negative 30, because negative 5 times 6, that gives me a negative. Positive 15 there, and then a positive 85. And now we're going to add that to, so now we're multiplying everything in the matrix by 2, so we're going to get a negative 30, 18, 58, negative 10, 34, and negative 4. So now we want to combine those two terms together by adding. Remember, we're going to go point by point. So negative 120 plus negative 30. And so this gives us the matrix of negative 150. And then we had 20 plus 18. That's going to give us a positive 38. So we end up with a 98 and then a negative 40 and then 49 and 81. All right. So now we're going to do another one, 4w minus z. What I would like to see is for the next three, I want you to pause the recording right here and take a moment to see if you get the same answers. So I'm going to pause the recording and then I'll come back with the answers. All right, so these are the answers to the last three. I am curious, how close did you get? Did you get the same answers for these? If you're having trouble with this, please reach out and then hopefully we can discuss this in class or in student hours. But that's it. That's the end of the beginning of matrices. Hopefully you didn't think they were terrible.